humans, I'm Mr. Khing. Yo, what's up? So now we're going to this past year paper, May-June 2021 paper 42. Alright, let's go. Okay, first one, Q1. See, even with the list of the elements here, so which one is measurable? Okay, see, we know that all metals, they are measurable. So answer it can be sodium, magnesium, or aluminium. Okay, because all metals, they are measurables. Okay, so which one will only 2 electrons in the outermost shell? 2 electrons means they are from group 2. So group 2, it has to be magnesium. Oxide that leads to acid rain, okay, non-metal oxide, but from here known as the main gas that causes acid rain is sulfur dioxide gas, so sulfur. Ions with -2 charge, okay, from group 6. So because group 6, they have 6 valence electrons, so therefore they need to gain 2 electrons, okay, become 2 negative. Okay, bauxite, remember, okay, bauxite is aluminium oxide. And which one do not form an oxide? Okay, see, it has to be group 8. Okay, group 8, they are stable. They do not react at all. Okay, then forms an oxide with a macromolecular structure. So from here we know it has to be silicon. Okay, silicon 4 oxide. And examples of giant covalent compound. Amphoteric aluminium. Okay, remember, okay, there are 2 examples of amphoteric oxide that you have to remember, okay, which are aluminium oxide and zinc oxide. That's it. Diatomic, we know that it has to be halogen from group 7. So Cl. And then forms a binary compound. So first, what is the meaning of binary compound? Binary compound means compounds that contains of 2 elements, okay, or 2 atoms. Okay, so acid, H, so which one? So we know it has to be Cl, HCl. See, total there are 2 different elements. Okay, binary compound. Okay, then given with this. Okay, so what is the name given to the atoms of the same element with different nucleon number? Okay, we know it is isotopes. Okay, then given with this, remember, okay, number on the top is always the sum of proton and neutron. Okay, number at the bottom left hand corner is just the proton itself. So which eventually we have 47, neutral 107 minus 47, you get 60 electrons. See, there is no charge. This is neutral. So same proton and electron. Another one, proton number 109 minus 47. See, positive 1. Positive 1 means there is 1 extra protons compared to electrons. So it is 46. Okay, next one, relative atomic mass. It is the average or mean mass of naturally occurring atoms of an element on a scale where carbon 12 atom has a mass of exactly 12 units. Okay, remember, atomic mass is obtained, okay, by comparison with carbon 12. It has to be carbon 12. Next one, you see a sample of silver has a relative atomic mass of 108. So deduce the percentage. So what's the percentage of 107? Okay, see, average mass 108. Okay, so this one you can carry out mathematics. Okay, so which eventually see 108 plus 109, okay, divided by x equals to 108. Okay, so which eventually, okay, you get x equals to 2, isn't it? So 2, it means half, okay, 50%. Okay, you divide by 2, okay, means 50% of it. Alright, Okay, then the formulas of acid which reacts with silver oxide to form silver nitrate. So the acid has to be nitric acid. Okay, then so describe, okay, what is seen when aqueous silver nitrate is added to aqueous sodium iodide. See, silver. See, whenever you see silver reacts to form silver iodide. So what is the observation for silver iodide again? It is yellow precipitate. Yellow precipitate. And then followed by ionic equation. Okay, let me see. whenever you see questions asking about ionic equation, it is always the ionic equations of the precipitate. So see, in this case, we know that the precipitate produced is silver iodide, solid. So we know that silver iodide is formed from silver ions equals and iodide ions equals. That's it. Yeah, you have to make sure that it is a balanced equation as well. But in this case, it is balanced. Okay, then for the porosity test of aqueous nitric ions, so sodium hydroxide and one other substance, they are warmed with nitric ions. So what is the another substance again? So how do we test for the presence of nitric ions? Remember, we test with the additions of sodium hydroxide solution and followed by the additions of aluminium. Okay, and the gas produced is ammonia gas. Okay, then name the types of reactions that needs light to happen. Okay, we know it is photochemical reaction. Okay, see, members of one homologous series, it only reacts with chlorine in the presence of sunlight. So name a members of this homologous series. So what is it? See, we know that the homologous series is alkane. Okay, only alkane can undergo substitution reaction. Okay, presence of sunlight, substitution reaction. See, you are asked to name a member. So in this case, you cannot write alkane. Okay, you are asked to name a member. So it can be any alkane. Okay, like example, methane. Okay, and what are the two products that form? Okay, when compound 1 reacts with chlorine, remember, see, during substitution reaction, they will always produce two products. Okay, so first, the organic products, it is called chloromethane. Remember, okay, during substitution reaction, only one hydrogen will get substituted. See, see. Then alkane that contains Cl is called chloro. Okay, chloromethane. And the inorganic products, it is called hydrogen chloride. Okay, please bear in mind you cannot write hydrochloric acid. Okay, HCl in the forms of gas, it is called hydrogen chloride. Okay, when HCl is in the forms of aqueous solution, then it is called hydrochloric acid. Okay, please take notes about this. Okay, next one. Okay, name the reactions. Okay, so you see, it is heated. You see, when the metal compound get heated, okay, it got broken down. So this is what we call thermal decomposition. And then, okay, calculation. See, remember, you see, mass of 1 mole, it is also the same as the relative molecular mass. So what's the relative molecular mass? You see, sodium 23, hydrogen 1, carbon 12, 1 oxygen 16, and they are total 3. So which eventually you will get 84. Okay, then what is the moles? So what is the information given to you? Okay, mass, isn't it? So therefore the formula to use is M/MR. So 12.6 divided by 84. If you press on calculator, you will get 0.15 mole. And then determine the numbers of moles of carbon dioxide. So in this case, okay, you have to compare the moles ratio. Say you found the moles for this. You compare with CO2. You see ratio 2 to 1. 2 to 1. So if the moles of sodium hydrogen carbonate is 0.15, so what is the moles of CO2? Okay, we divide by 2. So 0.15 divided by 2, we get 0.075. Right, okay, then calculate the volumes of carbon dioxide. See, volumes of gas. So formula N equals to V over 24 dm3. So 0.075 equals V divided by 24 dm3. So which eventually the volume equals 1.8. Alright, okay, then, okay, see, write the formulas of calcium hydroxide. Okay, pretty easy. It is Ca bracket OH2. Okay, why? Remember, okay, calcium 2 plus, OH negative. Okay, cross method, you get CaOH bracket 2. Okay, and then the white precipitate that forms when lime water turns milky. Let me see, when calcium hydroxide added with CO2, it produces calcium carbonate, CaCO3. Okay, next one, electrolysis. Okay, so state the name given to any solution which undergoes electrolysis. It is electrolyte. Okay, and then complete the ionic half equation, hydroxide. Okay, it's always 4OH negative to form 2H2O. Okay, then shows that the ionic half equations of hydroxide ions being oxidized. Okay, I mean like why? You asked to explain. Because it loses electrons. See, electron is written on the right hand side. Okay, electrons are produced. Okay, then observation at cathode. So you see, cathode. Okay, so first you see you need to know which one gets selected to be discharged at cathode. Okay, see, when it comes into electrolysis, the very first thing you have to do is list out all the ions present in the electrolyte. See, this is sodium chloride, so it contains sodium chloride, aqueous solution, that's water molecule, H plus and OH negative. All the positive ions to cathode, negative ions to anode. So which one gets selected? See, this is a dilute electrolyte. Okay, always pick the one that is lower in the reactivity series. So which one is lower? Hydrogen. So when hydrogen gets selected, so what's the observation? Effervescent. Of course, you can also write colorless gas bubbles form. Okay, both acceptable. Then ionic equation, hydrogen against electrons to form hydrogen gas, H2. Alright, then observation is given here. Concentrated sodium chloride. Same thing, you have sodium, you have chloride, hydrogen hydroxide. So what is the observation? First you need to know, so which one will get selected to be discharged? So you see, this is concentrated. So remember, you see, sodium, it can only get selected to be discharged in molten state. So which means in this case, hydrogen will get selected at cathode. And then how about anode? See, this is concentrated. If it is a concentrated electrolyte, the halide ions will always get selected. So the halide ions, see, that's chloride, isn't it? So therefore, chloride will get selected. So therefore, so what are the observations? You are asked about the observation. Do not write the products produced. So cathode, which one gets selected? Hydrogen. So observation, effervescent. Anode, chlorine gas is produced. So what is the observation for chlorine? You can write yellow or green gas. Either one will do, both acceptable. Then the student adds limers to the solution after the electrolysis of concentrated aqueous sodium chloride. So what's the color changes, and give your reason. See, if you look at this, see, we know that hydrogen gets selected, so no more hydrogen. Chloride gets selected, so no more chloride. So what is the electrolyte form? See, now left only with sodium and hydroxide ions. So therefore, the product's form, it is sodium hydroxide. See, remember, sodium hydroxide, they are examples of alkaline. So therefore, what's the color of the solution? See, in the presence of limers and it is alkaline, it turns blue in color. And then reason, because sodium hydroxide, which is alkaline, is formed. You have to mention sodium hydroxide, which is alkaline. You see, remember, do not just write sodium hydroxide is formed. You have to mention what is sodium hydroxide, and why it turns the limers blue in color. Because it is alkaline. Alright, then name another elements that can be used instead of carbon. See, as inner electrodes. See, what are the examples of inner electrodes again? So in this case, it has to be platinum. You cannot write graphite because both graphite and carbon, okay, they are the same. Remember, graphite is also made of carbon. Okay, in this case, you are asked to name another element. So you cannot write graphite. Okay, remember, okay, graphite is not acceptable in this case. Alright? Okay, then next one. See, given with this, okay, write the chemical equation. Okay, see, everything is given here already. Okay, so you see, we know that nitrogen reacts with lithium to form Li3N. Remember, okay, balance the equation. You see, left hand side 2N. Make it 2. After you put 2 over here, you see, there are total how many Li now? Lithium, okay, total 6. Okay, then complete the charge on the nitride ions. You see, first, you see, nitrogen, we know it is 2, 5. It has 5 valence. So, which means it needs to gain 3 electrons. So, what we have to do is, you see, given here, okay, the symbol for the electrons of nitrogen, it is cross. So, you see, 5 valence, 5 cross, it gains 3 electrons. So, the remaining 3, you have to use dot as the symbol. Okay, you cannot put all cross, no. You see, 5 valence against 3. So another 3 you have to represent with another symbol. Remember, see, this is what called dot and cross diagrams. You can only use dot and cross as the symbol, that's it. Okay, against 3, so the charge 3 negative. Okay, then given with this, the calculations of the bond energy. Okay, see, energy taken to break the bond. Okay, remember, it is always the total bond energy in the reactants. You see, reactant, see, there's one nitrogen, triple bond nitrogen. So 945 plus, see, there are 3 F what? Okay, 1 F to F bond is 160, but there are 3 over here. So we have to multiply with 3. So which eventually you get 1425. Okay, energy released to form bond, it is always the bond energy at a product side. See, this is NH3, NF3. Okay, see, there are how many NF? 1, 2, 3. So 1 NF, you multiply with 3. But remember, you see, there are how many here? You see, there are 2, isn't it? So you have to multiply with 2. So which eventually you get 1800. Then, okay, what is the energy change? Okay, so it is always the energy needed to break the bond minus energy released to form the bond. Okay, to look for the delta H. So which eventually you get 1425 minus 1800. You will get negative 375. So you see, so this reaction, it is exo or endothermic. See, the delta H is negative, isn't it? So if it is negative value, it is exothermic, and explain why. Okay, so now you have to compare, okay, the energy taken in, okay, with the energy release. So you see which one is greater? Energy release is greater, isn't it? So therefore answer, because the energy release is higher or greater than the energy taken in or absorbed. Okay, that's it. You just compare. Alright, okay. Then drawings of covalent compound again. Yeah, so you see how to draw this. Okay, maybe you see fluoride, we know it's 27, nitrogen 25. You see, fluoride, you see 27, it needs 1 more electrons to become stable, so therefore it can only share 1 electron. See, nitrogen, how many more electrons it needs? It needs 3 more, so therefore it can only share 3 electrons. Okay, so fluoride, see 7 valence, share 1, remaining 6 outside. Fluoride, share 1, remaining 6 outside. Okay, same goes to the another fluoride. See, nitrogen share 1, 2, 3. See, share total 3. See, 5 valence share 3. 2 more outside. Okay, so eventually this is how it looks like. Okay, then lithium nitride melts at blah 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 blah. So you see, okay, answer in terms of attractive forces, okay, why lithium nitride has a much higher melting point. Okay, and refer to the types of attractive forces between particles. Yeah, between particles and the strength. Okay, so you see first, okay, what is the force present Okay, so we know lithium nitride, it has ionic bond. Okay, it has ionic bond. So we know that it also see, it has strong electrostatic forces of attraction. Okay, between what? So what types of particles in ionic compound? Ions, isn't it? So between oppositely charged ions. And so this is how you get 3 marks. Ionic bonds, strong electrostatic between oppositely charged ions. Okay, then percentage by mass of nitrogen in ammonium nitrate. So you see, there are how many nitrogen here? Total 2, isn't it? And one nitrogen is 14, there are total 2. And you look for the mass, the total mass of the compound. So 14 plus 4 hydrogen plus 14 plus 3 oxygen. So which eventually, you have to multiply with 100%. So which eventually you will get 35%. Okay, then what's the use of ammonium nitrate? Okay, ammonium compound, okay, they are used to make fertilizer. Okay, and state the names of a compound that will displace ammonia from ammonium nitrate. See, let me see. What is the compound that will react with ammonium salt to produce ammonia gas? It has to be alkaline. Okay, so it can be any alkaline like sodium hydroxide, potassium hydroxide, calcium hydroxide, as long as it is an alkaline. Next one, okay, definition, okay, define the term base. Okay, base means proton acceptor. Okay, please do not write what substance that dissociate in water to produce hydroxide ions. No. Okay, this is not the definition. Okay, remember base, okay, or alkaline. The definition is always proton acceptor. So what's the pH? See, ammonia is an example of weak alkaline. Yeah, so pH it can be 8, 9, or 10. Alright. Okay, then given with this, polymerization. Okay, so name the functional group in B. So you see, what is the functional group? COOH, isn't it? And COOH it is also called carboxyl group. But of course, you guys can also write carboxylic acid. Yes, acceptable. Okay, because all carboxylic acid contain COOH group. Okay, then draw the parts of the structures of the synthetic polymers that would form when 2 molecules of A and 2 molecules of B combines. Okay, so how to draw is mentioned here already. You have to draw 2 molecules of A and 2 molecules of B. See, this is condensation. So condensation happens by removing by removing this byproduct, so-called H2O. Yeah, which means you have to take away H and OH. Remember this, always take away the OH from the COOH and then take away H from another monomers. Alright, so which eventually, okay, it will look something like this. Okay, O, CO. Okay, you need to follow the patterns of the box. Okay. See, eventually it looks something like this. Okay, one more thing, see, you have to make sure that both the end of the drawing, always leave it with extended bond, okay, to show that it's still joining with some other monomers. Okay, see, and it's mentioned here you have to draw 2 molecules, okay, for both the monomers. So how do you know? See, based on the repeat units of the rectangular boxes. See, 1, 2, okay, 1, 2. That's it. So this is how I get 3 marks. Alright, okay, then, okay, what is the products form? See, so what is the byproducts produced? Water. Okay, then molecules A is a simple sugar unit which can be made by hydrolysis of complex carbohydrates. So draw parts of the complex carbohydrates that could be hydrolyzed to make molecules A. So include one linkage and show all the bonds in the linkage. See, so which means you are asked to draw what? Carbohydrates. Okay, so how do you draw carbohydrates? Okay, remember carbohydrates, it is just O. Okay, remember, okay, whenever you're asked to draw carbohydrates, okay, always include minimum 3 repeat units. Okay, then what are the 2 sets of conditions that are needed to carry out hydrolysis? Okay, remember, it is acid and heat or enzyme. Okay, so these are the 2 sets of different conditions that are needed. Okay, then what is the technique that can be used to identify the sugars unit, okay, produced from hydrolysis? Remember, you see, okay, the method that can be used to separate all the natural monomers or natural compound, it is always chromatography. Okay, the next one, okay, ethanol, it can be made from simple sugar glucose. So what is the names of this process? It is what we call fermentation. And what's the chemical equation? See, glucose undergoes fermentation to form ethanol, C2H5OH, and carbon dioxide gas. Balance the equation, 2, 2, that's it. Alright, okay. So that's all for this paper. Thanks. Remember to like the video and subscribe to the channel. See you again. Bye.